Math 7, Unit 10, Target 10-6. 10-6, I can solve two-step inequalities and graph the solution. Again, we are using no negative coefficients. Review, solving equations. Solving two-step equations, we're going to run through a really quick review before we do inequalities. When you're solving a two-step multiplication equation, you draw your line of equality down your equal sign. You first need to zero out your 2, which means you're going to subtract 2. And in order to keep equality, you must do the same thing on the other side. 3x is going to be equal to 15. In order to undo the multiplication, you need to divide by 3, which means you need to do the same on both sides. X is going to be equal to 5. Check your solution. 3x plus 2 equals 17. Substitute. 3 times 5 plus 2 equals 17. Order of operations. 3 times 5 is 15 plus 2. 15 plus 2 is 17, which equals 17, so it checks. We got it correct. Second one, dealing with division. Again, we draw a line of equality. We need to add 8 to both sides in order to zero out the 8. X over 2 is going to be left on this side. Negative 2 plus 8 is going to be 6. In order to undo the division, x divided by 2, we're going to multiply. 2 over 1. 2 divided by 2 is 1. That's our goal, 1x. If we multiply by 2 on one side, we must be fair and do the same on the other. 6 times 2, 12. X is equal to 12. We must check. X over 2 minus 8 equals negative 2. Substitute. 12 over 2 minus 8 equals negative 2. 12 over 2 means 12 divided by 2, which is 6. Minus 8 equals negative 2. 6 minus 8 is negative 2 equals negative 2. It checks, so we got it correct. Moving on to inequalities. We are going to solve the same as equations. We're going to draw our line. The first thing we're going to do is subtract 2 from both sides in order to get rid of the 2. We're left with 2x is less than, we keep the symbol the same, 10 minus 2, which is 8. In order to get x alone or get 1x, we need to divide by 2. We need to do the same on both sides. X is going to be less than 4 as our solution. In order to graph that, our boundary point is 4. We're going to put in some other numbers. It is less than, so it's going to be an open circle. X is smaller than 4, so we're talking about all values smaller than 4. In order to check, we need to pick a value that's been graphed, so something smaller than 4. Let's pick 2. To check, we're going to rewrite 2x plus 2 is less than 10. Substitute 2 times 2 plus 2 is less than 10. 2 times 2 is 4. 4 plus 2 is 6. 6 is less than 10, so it checks. We got it correct. X over 5 plus 7 is greater than or equal to 12. First thing we're going to do is get rid of our 7 minus 7 from both sides. X over 5 is greater than or equal to 12 minus 7. Which gives us 5. In order to undo division, we need to multiply. So we're going to multiply both sides by 5. Fraction form is 5 over 1. 5 divided by 5 is 1, which is our goal. Multiply by 5 here. 5 times 5 is going to be 25. X is going to be greater than or equal to 25. Graph it. 25 is our boundary point. I'm going to put in some other points. It is greater than or equal to, so we're going to have a closed circle because it could be equal to 25. X is larger, so we're talking about all values greater than or equal to 25. We're going to check. First thing we need to do is rewrite x over 5 plus 7 is greater than or equal to 12. Pick a point that's been graphed. Let's pick 26. 26 over 5 plus 7 is greater than or equal to 12. 26 over 5 is something we have to do first, which means 26 divided by 5, and that is going to give us 5.2. Plus 7 is greater than or equal to 12. And 5.2 plus 7 is going to be 12.2. 12.2 is greater than or equal to 12, so it checks. We got it correct. Example 3. Solving for x. First thing we need to do is zero out the 6, which means we're going to add 6 to both sides. 4x is less than or equal to 8. In order to isolate x, we need to divide out the 4 from both sides to be fair. X is going to be less than or equal to 2. Our boundary point is 2, so when we're graphing it, we're going to put 2, put in a few more values. It is less than or equal to, so it's going to be a closed circle because it could be equal to 2. X is smaller, so we're going to talk about all values smaller. Check. In order to check, we're going to rewrite 4x minus 6 is less than or equal to 2. We need to pick a value that's been graphed. Let's pick 0. 4 times 0 minus 6 is less than or equal to 2. 4 times 0 is 0. Minus 6 is less than or equal to 2. 0 minus 6 is negative 6, which is less than or equal to 2. That is a true statement. It is less than, so it checks. Example 4. Again, we need to solve for x. In order to do so, the first thing we need to do is zero out the 9 by adding 9 to both sides. X over 12 is going to be greater than 27 plus 9 is going to give us 36. We need to multiply both sides by 12. 12 divided by 12 gives us our 1x we're looking for. And 36 times 12 is going to give us 432. X must be greater than 432 is our solution. 432 is going to be our boundary point. Put in some other values. It is going to simply be less than, so it's going to be an open circle. And we are talking about x being larger than 432, so we are going to graph everything larger. Check. In order to check, we must first rewrite x over 12 minus 9 is greater than 27. Substitute, let's put in 434. 434 over 12 minus 9 is greater than 27. Divide 434 divided by 12 is going to give me, I'm going to round, 36.17. Minus 9 has to be greater than 27. 36.17 minus 9 is going to be 27.17, which is greater than 27, so it checks. Our solution is correct. For the next two examples, pause the video, do the work, then hit play and check your work. Go through these quickly. In order to isolate x, you're going to add 10 to both sides. 2x is greater than or equal to 10 divided by 2. X is greater than or equal to 5. 5 is your boundary point. Greater than or equal to means it's a closed circle, and x is greater, so you're going to talk about everything larger. Check 2x minus 10 is greater than or equal to 0. Pick a value that's graphed. Let's pick 7. 2 times 7 minus 10 is greater than or equal to 0. 2 times 7 is 14 minus 10 is greater than or equal to 0. 14 minus 10 is 4. 4 is greater than or equal to 0, so it checks. Solution is correct. Again, you can use anything for the check as long as it's a graphed value. This one, second one, you're going to subtract 9 from both sides. 13 minus 9 is going to give you 4. X over 4 is going to be greater than or equal to 4. Multiply both sides by 4 over 1. X is greater than or equal to 16. Graph it. 16 is going to be your boundary point. 16, put in a few more values. We are talking about things greater than or equal to, so we're going to have a closed circle. X is larger. In order to check, we're going to rewrite x over 4 plus 9 is greater than or equal to 13. We're going to substitute something that's graphed. Let's go 18. 18 over 4 plus 9 has to be greater than or equal to 13. 18 divided by 4 is 4.5, plus 9 has to be greater than or equal to 13. 13.5 is our result, which is greater than or equal to 13, so it checks. Today we talked about how to solve two-step inequalities and graph the solution. Remember, you're solving just like you were solving with equations. When you use your check, make sure you use a value that's been graphed.